question 2 of the acids and bases worksheet. Again, this is taken from the Northern Cape paper from 2000. It's also the higher grade paper. Still valid for what you learn now. So now they tell you that 500 centimeters cubed of dilute hydrochloric acid of concentration 0.25 is added to 500 centimeters cubed of sodium hydroxide. The temperature of the solution rises, it gets hot, and the pH changes to 2.3. First thing they ask you to do is classify this reaction as exothermic and endothermic. No reason needed. The temperature increased. That makes it exothermic. You feel it get hotter. If it gets hotter, it means it's exothermic. Okay. Now, the final concentration of the H plus ions, that comes from the 2.3. If you've looked at question 1, then you know that if the pH is the negative log of the H3O plus ions, now this is the difference with how they would ask this now. They wouldn't say H plus ions here, they'd say H3O plus ions. It's the same thing, okay? Which means the concentration of the H3O plus ions is equal to 10 to the negative of whatever the pH is. So this is 10 to the negative 2,3, and what that gives me is 5,01 times 10 to the minus 3 moles per decimeter cubed. Then we get to the initial concentration of the sodium hydroxide solution. This is a difficult question. Okay, it's worth 8 marks. That means you're going to have to do several steps with it. Okay, so taking this one step at a time, not getting all flustered. Okay, but we have HCl, which is reacting with sodium hydroxide. It's going to give us NaCl and H2O. Okay? Initially, for the HCl, I know that I have a concentration of, so this is my initial concentration of 0.25 moles per decimeter cubed. I know that the volume is 0.5 decimeters cubed. Okay? Then we also added 500 centimeters cubed initially. So I also added, I'm going to use a different color for the base. I added a volume of the base of 0.5 decimeters cubed. And I know at the end, okay, so when I get to the end, I know that I have the H3O plus concentration, we've just worked it out, is 5,01 times 10 to the minus 3. Okay? What that means for me is this is what's left over when the HCl and the NaOH react with each other. Okay? That's what's left over. So, this is a comparison thing. What I need to work out, okay, is how much NaOH reacted with the HCl. Okay? They didn't tell me, now watch. They didn't tell me, and this is important, they did not say that 500 of each of those completely neutralized the other. They did not say that. Okay, because we have a strong acid with a strong base. If there was a complete neutralization, so we added just enough of both of them, my final pH would need to be 7. Because my final pH is not 7, it means I've got HCl left over. So what we're going to do is this. This is my final concentration. Okay, let's work out the initial number of moles. And I'm going to explain, just go with me, initial number of moles of HCl. Well, concentration, number of moles over volume, this is 0.25, number of moles over 0.5, so N is 0.125 moles. Okay? At the end, so that's initially, that's what I start off with. So we're going to keep that in our mind. At the end, I want the, let me write this properly for you. What I need to recognize is the concentration of the H3O plus ions is equal to the concentration of the Cl minus HCl, because there's only one hydrogen per molecule, so it's a 1-to-1 relationship. That means concentration, number of moles over volume. Concentration here is not the issue. Volume is. You need to remember here that, okay, we had 0.5 moles per decimeter cubed of the acid. We then added 0.5 decimeters cubed of the base. My total volume is now 1 decimeter cubed. This is very important. That's the trick to this question. Okay, we added the two together, so number of moles is going to be 5,01 times 10 to the minus 3 moles. So I had 0,125. I've ended with 5,01 times 10 to the minus 3. What does that mean? Well, if we now go, the number of moles of HCl that would be neutralized is the difference between those. So I had 0,125. I'm going to minus the 5,01 times 10 to the minus 3. And that's going to give me 0,12 moles. You can put it in your calculator, but you can trust me. Okay? That means this is the number of moles that took part in the reaction. That was the hard part. If I told you that that was how many moles of HCl we'd used, and now I say to you, work out the concentration of the NaOH, you can do this. I know the volume of the NaOH. I now have enough information to get the number of moles of the NaOH, because it's going to be 0,12 moles times 1 over got. So I have 0,12 moles of NaOH. And what do we know? Concentration, number of moles over volume, and we get 0,24 moles per decimeter cubed. Now it's close to the HCl. It's very close. That's okay. Not completely close. Okay. So what that means is the reason why the HCl didn't get completely neutralized is because they weren't identical. If the NaOH and the HCl were absolutely identical in concentration, we wouldn't have had this left over. All of the HCl would have been used up. Okay, so essentially, because this is a lower concentration, this is like the limiting reactant, it stopped the reaction before all the HCl was neutralized. This was a difficult question. You may need to watch this video again, okay, and pause it as you go through it to just try and think through things. But this one is very difficult, okay.